Like to meet you again after the 1 year, and I'm so very glad to happy to see all my friend, for example, Professor Latinovic, my friend Dean, the faculty from Hunedvara, Ovidiu Tirian, and a lot of friends from Hunedvara, Carmen Alik and his daughter, etc. So happy to see you again in the virtual platform, and I hope we will see in the next time by online, not only online. And okay, I would like to start my first article and presentation with the name "A New Approach for Creating and Testing Safety Components Integrated into a Robotic Cell Simulation Scenario in a Virtual Reality Environment." The content of my presentation is divided to the 5 section. Aim of the work, a new approach for creating testing safety components integrated into a robotic cell simulation scenario in a virtual reality environment. Testing the simulation robotic cell and safety components implemented into the virtual reality environment in Robot Studio software. And 4 point is the results, and last point is the conclusion. The first, the point of my presentation is aim of work. The aim of this work is to show new possibilities of using modern technology in the form and integrating several safety components into the simulation scenario of the selected robotic cell, visualizing them and testing their functionality in the virtual reality environment by the Robot Studio software. As a test model of the robotic cell was using digitalized version, such as a digital twin of the presentation robotic cell of the company ABB, in the digitalization of which our department participated in the project between the employees of the department and our students who solved the diploma thesis there and in the company ABB. The highlight of this work in the interconnection of currently available and most used safety components of the real robotic system with focus on visualization and the most realistic simulation possible of the functionality of safety component in virtual reality environment, such as safety laser zone scanner, light barrier, emergency stop button, contactless security door sensor, and last, light signalization. The second point is creating an integration of safety elements into the simulation scenario and virtual reality environment in Robot Studio software. As part of the simulation scenario in the Robot Studio software, CAD models were integrated and subsequently reviewed with the necessary functionality as in a real robotic workplace. The integrated safety components were 3D CAD models of currently available safety components from renowned brands such as SICK, Allen Bradley, Rockwell Automation brand, etc. was used in my simulation. It is especially about light signalization, switching on and off the station using buttons, safety functionality of the light barriers, and simulation of safety laser scanner functionality. The Robot Studio software makes it possible to create even more complex processes within virtual reality, but for their functionality, it is necessary to create a specific smart components or ensure certain functionality be programming in rapid language, because the Robot Studio used for the programming rapid language. The third point is integration and programming of safety components in Software Robot Studio for visualizing and testing of functionality in a virtual reality environment. The first safety component was used the safety laser zone scanner. The principle of functionality and operation of the laser scanner consists in slowing down the robot's activity, especially in slowing down its speed. In the simulation scenario, we define it, the speed will slow down to 30% of the original speed, which was originally 100%. After leaving the safety zone, the speed will return to the original 100%. The detailed functionality and the definition of the principle of operation of the laser scanner will be described in the detail in will be described in a research article. The second safety component used in my simulation was a light barrier. The light barrier is a safety element that stop the operation of the robot cell when the signal of this barrier is interrupted. This light barrier sends the permanent amount of light rays to the
Radovan, we don't see your slides.
Oh,
Okay.
Thank you. I don't know why. Excuse me, just a moment, please.
Yes, now is okay.
Now it's okay.
Yes.
But now I don't have in a presentation mode. I don't know what is problem.
This is quite okay. Continue in this. If you have presentation mode, you must share the windows, the other windows.
Okay, da, yes.
Yes, you must share the windows, window, and after
Now
okay.
Now you see or no?
See, yes.
Everything is okay now?
Yes, everything is okay.
I can continue. Thank you so much.
Yes, okay.
The light barrier is a safety element that serves to stop the operation of the robot cell when the signal of this barrier is interrupted. The light barrier
Nu mă
sends...
mai suna, Nelu, că sunt conferință. Și ești chiar pe internet, mă suprapui pe conferință.
What?
Okay.
Okay. In the simulation, however, for the functionality of this safety component in the virtual reality environment, it was necessary to replace the signal with 3D object, as the controllers were unable to detect a signal from a sensor such as a plane sensor. The 3D object of the sensor was created as a simple geometry in the Robot Studio software with the pre-thesis object transparency has been set to 1% of its original value. You can see the transparent object. It was created in Robot Studio environment and used in the virtual reality environment programming by the smart components in the left picture. The other one safety component was used the emergency stop button to turn the station on and off. Using the buttons and create this functionality, a kinematic mechanism of start and stop buttons was created in the form of defined linear movement when starting and turning off the button. The operation is secured through the newly created smart component, button virtual reality component. The principle of operation of smart components consists in monitoring the position of individual mechanisms using joint sensor. You can see in a left picture, this is a two square joint sensor, and the data of the position of the mechanism is subsequently provided to the comparer, in which if the measure value is greater than 0, it's sent the signal future. And the start button, the signal is sent via the start digital output directly to the virtual controller using station logic. The stop button sends the signal to two sources.
Please, Radovan. Also, we are on the side of light or on the slide of light barrier. Please move this.
Oh, I don't know why. What's the problem?
Move it. If you start.
Okay. I will try only with.
You share a window. You just share a window or the screen. If you have a tool.
Okay. Just a moment, please.
Share a windows or the screen that maybe is easier that you share just this
screen window. Yes, of course, but
if you have a two screen, you put.
Yes, of course, I understand.
On one screen. And it's okay.
Now it's okay.
We are now looking a light barrier, nothing more.
Okay, just a moment, please. Just a moment, please.
Share one
application window. Yeah, share.
Okay.
Your screen sharing.
Yes. Okay.
Now it's okay.
Now is much better. Please stop on this and continue presentation. Thank you.
Okay, I don't know why it's a problem. Maybe with two monitors. Usually. I have two monitors. Okay, now I can continue. Okay. You see the slide emergency stop button now, yeah?
Yes.
Okay. The stop button sends the signal to two sources. The first in the stop output signal. The second output goes to the execute command simulation step component, which if it detected signal change to 1 at its input causes the entire simulation to stop immediately. The other one, safety component, is contactless security door sensors. Another safety component is non-contact sensor of each door of the robotic cell. The functionality of these sensors in that if any door is opening during the simulation, the entire operation of the robotic cell will stop immediately. For this purpose, already created door mechanisms are used in the simulation and the logic added to them using smart component. The principle of operation is based on the principle that each door in the robot station has its own sensor, joint sensor, at its comparator. If the position of the mechanism is greater than 0, then the signal is sent to the execute command simulation steps components and the simulation stop immediately. And the same time, the signal is also sent to the stop output signal. This functionality is the same for all doors in the robot station. The last safety component is light signalization. The light signalizing has 3 displayed states in this robot station. The first state is shown in green. It informs about the full operation of the robotic cell. The second state is shown in orange. This color light up when the safety zone of the laser scanner is violated, and thus the speed of the industrial robot is slowed down. The third state is shown is red, which occurs when the robotic cell stops. In the software, it is on displaying the state of the created hemisphere object, which subsequently changes its color using the defined smart components. Now I would like to show you the final simulation scenario with safety components integrated into a robotic cell in a virtual reality environment. You see the simulation?
Oh, super.
Okay, thank you so much for information. The start simulation by the start button. Everything is created in the virtual reality environment. Now you can demonstrate to see the laser scanning function in virtual reality. The violating the safety zone, the laser scanner slowed the robot down at 30% of its original speed. And after leaving the safety zone, the robot accelerated back to its original speed. It was a simulation, the safety scanner, light barrier. Now it's if the reset the simulation after there has been stopping by breaking the light barrier, it's necessary to restart simulation via the start button. Now it's demonstrate light signalization. I describe the light signalization has three status: green, orange, and red. You can see
Okay.
red. Okay, and now it's changing the status: green, orange, or red. Now I would like to demonstrate emergency stop in the simulation. After pressing the central emergency button, the robot simulation must be stopped. And now I would like to demonstrate contactless the door. When it's open, by opening any door, a robot simulation stops immediately. Yeah, this demonstrates safety components. And after the door is closed, again, the robot simulation in the virtual reality environment is restarted using by the start button. And you can see some simulation of the robots, manipulation to the conveyor. And everything was visualization in Robot Studio software. And after the programming, everything was testing and debugging in the virtual reality environment. The 5 is results. Results of this work is created is the final robotic program in rapid programming language for real use of an industrial robot is created, which integration of several safety components and programming of logic in Software Robot Studio. Subsequently, the functionality of all security components was tested in a virtual environment. All safety components integrated into the robotic cell solved in identical behavior and performance parameter as if they were integrated in a real robotics systems. And the last point of my presentation is conclusion. The simulation of robotic cell in virtual reality environments compared to the classic simulation gives a better visual idea and the possibility of understanding the functionality of several simulated areas. In virtual reality, the user can physically test various elements of the station, such as a movement of individual mechanisms, setting the industrial robot in different positions, verifying the reach of the robot, simulation individual work cycles from a better perspective, and above all, physically testing the creating safety components, which was also the main goal of this research. These safety components that were presented were created with a real functionality in mind, and therefore it is not possible to try and test them in a standard desktop simulation environment. In virtual reality, it is also possible to edit the program within the parameters of the individual robot, such as its speed, zone, or configurations. It is also possible to change the layout with the grep function. A great advantage is the possibility of virtual meeting and consultation in which 2 or more users join a single study in real time, in which they can subsequently use the maintained functionality, for example, draw graphic elements or create nodes. The last of the option is the trying of future employees in a virtual reality environment, as the simulation was created in the 1:1 ratio with the real activity of the robotic cell in cooperation with MTF, STU, and ABB Slovakia. The main fulfillment of the goal of this research was the integration of safety components, their programming and functionality testing, so that they behave in a virtual reality environment as in a real robotic system. For example, I have the future research and future work. The various simulation scenario created in this way in the future with the integration of various functionalities in the virtual reality environment gives enormous potential and enable great flexibility in the training process as the activities of the physical robotic cell in the production process thus do not have to be stopped, which save time, but mainly the functionality, resources, and various production companies. Thank you so much for your presentation by my first presentation.
Okay. Does anybody have any questions for Professor Radovan? If you don't have any questions, I will just want to say that Professor Radovan Holubek built his laboratory in the time of COVID and give possibility to all students to have a laboratory works with the virtual reality systems. It means that all the first laboratory was virtualized and have possibility to access to it. It was, I think, the first time that I saw such a complex task to be finished somewhere in Europe, and I always promote dear Professor Radovan for this virtual reality because this way will be in Education 4.0 one of the way of teaching students in the future.
Thank you so much,
Thank you,
Professor.
the Radovan for first and